All right. Well, welcome to the second best talk of the conference. All right, and why is this the second best talk? I'll tell you in a little bit. So I am the CISO for Lithomic. I have to tell you a little bit about Lithomic. We are a software company that builds a cloud-based platform, primarily using AWS for healthcare data. So lots of patient data, lots of genomic data. We work with medical institutes and hospitals and so on to help them do their cancer research and use data to do machine learnings and studies and so on. And we also have a set of mobile apps that uses the platform for the back end as well, and the mobile apps are directly patient-facing, consumer-facing. Now, additionally, I'm also the founder of JupyterOne. JupyterOne is a cloud security product. Now, I'll tell you about that in a little bit as well. So we're a startup, right? So as a startup, we are very engineering focused. We are cloud native. And with the small team that we have, we actually do over 20, sometimes up to 50 production deploys every day. And earlier, there was a speaker who asked the question, who are automating 90, 100% of their production deployments? We are. We are automating nearly 100% of all of our production deployments. Now, but that said, we are also in a highly regulated industry. We have to be HIPAA compliant. We have to be GDPR compliant. We have to get through different kinds of security certifications. But how do we do that? Now, how do we do that at that speed without slowing down? Now, that's what I want to talk about today. So today's talk, I don't have any slides on market trends. I don't have any news to share you, and I don't have any statistics on certain things. But what I will share are the ways that we do DevSecOps, or how do we accomplish and overcome these challenges in a cloud-native environment. So the developers in the room, by a quick show of hands, who here do not have admin access to their local machine but wish they do? Nobody? Just one? Everybody else has admin access to their machine? That is good. All right. For the security folks in the room, by a show of hands, who thinks developers don't care about security? Only one? A half. Now, I'm not talking about developers who are not capable of writing secure code or who hasn't been trained or certain things, but developers, if you think that they don't care about security, I offer you one solution. There are bad developers. You should fire them. All right, so that said, first and foremost, are we having this issue again? Okay. First and foremost, that I really think that security is an organization challenge. I'll talk about this in two aspects and how we deal with it. One is on the organizational aspect and people and culture aspect, and second is more kind of technical implementation challenges. So what is DevSecOps? And the better question to ask is, how do security, or how does security keep up with DevOps at the speed? We've probably heard many definitions of DevSecOps. We've heard about the concept of shifting left. Now, this is what I offer as our view of DevSecOps. Now, I actually think that DevOps and DevSecOps are very, very similar. We all have very similar goals. We all want the same things, which is to move fast and automate everything you can with confidence. Now, that last part is the most important part, is with confidence. Developers want that as well. It's not just security people. Right? Developers want their code to be scalable and to be reliable, so to produce quality code. And again, I'm talking about the good developers, right? Not the ones that you should fire. Now, on the other hand, there are differences between DevOps and DevSecOps. First and foremost is about culture. And second is about the actual tools and technologies and the process and implementation of DevOps or DevSecOps. So with DevOps, and everybody's familiar with continuous integration, continuous deployment, or continuous delivery, CI/CD. Now, the way I look at DevSecOps is continuous assurance and continuous compliance. So now, before I get to that in detail, I want to talk about the culture piece a little bit. So are we all familiar with the Agile Manifesto? So I think a lot of people are. Now, I offer a manifesto for modern cybersecurity. This is something that we've developed internally and we've published on securitymanifesto.net. And this is the way that we think modern security operations should work and should function at an organization level. So there are 6 things to it. These are very simple and easy to understand. These are the things that we tell ourselves, or I tell my security teams, and we work together with the development teams to come up with these. Now, first of all, is to assume compromise, but expose no single point of compromise. What does that mean? Right, so in terms of implementation, that means zero trust. And that's how we implement it. And we basically said, in our production environment, we allow no network access, no direct network access, no VPN, no SSH into our production environment at all. We use almost 100% serverless. In AWS, that's Lambda functions and the platform services around it. Now, that's just one example of zero trust, and there are many others. Now, the second point is to track everything, because you cannot protect what you don't know or what you can see. So what is the implementation around that, right? So for that, we said you have to have an asset configuration management database. You have to, first and foremost, be able to do proper asset inventory. Now, this sounds so basic, but I would argue that most people don't do this well. Most organizations don't. It is a very, very challenging problem to solve, asset inventory. Now, the third one, engage everyone, because there's power in the crowd, 2 is better than 1. Our approach to this is we do not want security to be the responsibility or the task of just the security team. Well, we all understand this by concept, but how do we do this? Is we have to engage developers, we have to give developers power, we have to empower them to make security decisions. And of course, bug bounty program. Right? So we are pretty open and public about what we do with our bug bounty. Number 4, automation is key because people don't scale. So this is where we're going to focus a lot more in the talk as I go on the security as code. There are multiple aspects to how we use automation in security. And 5, build products that are secure by design and by default. So what this really means is you need to have threat model. And I'll offer some examples of how we do threat model, or I would call threat model light, in a way that developers can participate and help with the threat modeling exercise. And last, just sort of to sum it all, is we have to keep things simple and usable and open, right? So that it can be adopted. If it's too difficult, people won't do it. That's just the reality. And also be open, right? Not talk about security behind closed doors. We actually discuss security incidents and issues in open Slack channels. And we also publish our policies, security policies, and not just that, but procedures publicly on our website. Not a lot of companies do that. So we want to be very open about what we do when it comes to security practices. Now, I have been challenged on that, right? So I've had people tell me that you're crazy. You're just showing everybody how you do security. And I say, yes. If that causes a problem, if that causes a breach, there's a problem with that, right? If just by telling people how you are operating, that may cause risk and issues, there is a problem in that. So that is sort of the higher level aspect of kind of the philosophical decisions that we've made in how we as an organization want to operate. Now, I want to get down to some details, right? So how do we enable this, right? So I talked about some higher level kind of program and implementation ideas, but how do we actually implement this? So I want to talk about this in 2 aspects of DevSecOps. Now, the first of these two would be, how do we use security as an enabler for DevOps? So there's what that means is the whole shift left concept, right? So how do we automate these security checks, the approvals, and the workflows, and the gates, and so on, in your full pipeline, in your development pipeline? Now, this is something that my colleague Matt is going to talk about. He's going to give a session tomorrow with very detailed examples and our implementation of the automation and the bot that we created for doing this. So remember I said this is the second best talk of the conference? Well, now you know why. Okay. The second part, which is what I'll focus on today, is development as an enabler for SecOps. Now, when I say SecOps, it's not just running a SOC, right? Running a security operations center. It's more about knowing and understanding your security environment. And also compliance. I don't see compliance as a separate aspect or a separate initiative from security. It should be part of the same things. It should just be a natural outcome of doing security correctly. So what do these mean, right? So how do we do it? One is we aggregate data from the source to gain visibility and insight. That's the visibility part of it. And we also automate the operations with code and manage artifacts that we can generate for compliance and for auditing and so on using code. And that is the governance aspect. And last is we want to achieve provable security with continuous assurance and continuous compliance. Now, what does this look like? So this is our program, and I think this journey is probably very similar to many other organizations. So as we started building out the security program, we said, okay, we have to do these things. We have to understand our data, understanding the data flows, do risk analysis, and write policies, procedures, create the infrastructure with the security tools and controls in place, and implement all of these things, right? So there could be over 100 different controls that you might need to implement, and some of these are tools, and some of these are processes, and so on and so forth. And then you have to add in the compliance aspect, right? So you have to have auditors, you have to do collect evidences and do assessments and certifications, and after that, you still have to run the program. You have to continuously monitor, manage, and optimize all of the security solutions and controls you have in place. Now, this is a repeated effort. Now, imagine you being the security team or the compliance team doing all of that, right? So not only do you have to collect data the first time for whatever audit or compliance that you have to do, but you have to be able to do this continuously, time and after again. Now, looking at this, I don't want to be that guy, or nobody on my team wants to be that guy. It is tremendous work, and it is non-value added work. It's just tedious amount of work on a day-to-day basis. So how do we solve this? So the way we attempt to solve this is by aggregating data from the different sources. So what happens here is we've created a set of tools and set of automations using data, right? Because essentially, at the end of the day, all of these is just data that comes from different sources. And we've put them into a graph by analyzing the relationships of these data so that at the end of the day, we can ask questions and get answers using queries. So that is fundamentally how we solve this challenge, is to say, can we run security and compliance, by the way, by as simple as asking the right questions and getting the right answers back from data. So I'll get into details and show you examples and screenshots of what that means. So why graph, right? So I look at security and compliance as a data challenge. And as I mentioned, we solve this by using data and graph and query. But why graph? Well, about a year ago or so that I actually got this phrase from a DevOps lead at Microsoft, and he told me that attackers think in graphs and defenders think in lists. That's how attackers win. And I've been using that phrase ever since. And that is so true because the relationships from a graph is what gives you context, is what helps you understand your data, is what answers the question, so what? So when you have a set of information about your environment, from a configuration standpoint, from an asset standpoint, does it matter if a certain device is configured a certain way? Let's just say if you have a certain server or workstation or instance that is not encrypted, or maybe it has open access to everybody. Now the question is, so what? Does it matter? So the only way to have that answer is to understand the relationship between an amount of those resources and entities. And that is what we created using Graph. So this is a simple screenshot of what Graph is, right? So the graph is just a set of nodes and relationships. Each node in there, right, so this simple example that you see here, represent a digital resource in our environment. It's something that is in our environment. And then the connections between them represent how they interact with something else within the same environment. Well, there could be a lot of those things, right? So there could be thousands or even hundreds of thousands of entities or assets or resources, whatever you call them, in a digital environment. And on top of that, there could be millions of relationships. How do you make sense of them all? So even if we are able to aggregate that data and build out those relationships in a graph, how can you digest it? Now that is the next challenge. That's why we build a set of queries so you can ask questions and get answers, right? So that's what I mean by that. I'll get into more details. So first, when we say entities, what do we mean by entities or assets? Now a lot of people think about assets as servers or laptops or these IT assets. But the approach that we took to asset is digital entity that represents something meaningful in your environment, that has value in your operations. So these are some examples. So this is our data model that we've used. And these are all what we say as the asset class within our environment. Now notice that there's no vendor-specific or technology-specific terms in this data model. We don't look at things as EC2 instance in AWS or an S3 bucket in AWS or so on and so forth, or a SQL database. Now we look at these as a higher level, a generic asset. And the reason is, now the way we've built this data model is to achieve a goal that once you've built these questions, even if your underlying technology changes, all we have to do is remap or re-ingest the data so that you don't have to change your automation query as your technology changes. So now I'll give you some examples. I'll use AWS as my first examples. We are almost 100% in AWS. So within AWS, there are many things that you probably want to understand for your AWS environment. Right? So here's one. The question is, which EC2 instances are exposed to the internet? Now what you see here is a graph. Now what this graph is showing you is actually down there, if you can see near the bottom middle of the graph is the internet node, and it has connections to security groups, and from that point on it has connections to EC2 instances. And then also after that, right, so below, on top of those are the networks that these instances belong to. Now, in order to come to this picture, right, in order to answer this question to say, are there instances exposed to the internet, is not as simple as one configuration. Now, what you see here is a fairly complex traversal of a graph to derive at that answer. You have to know that the instances have public IP addresses. They are part of a public VPC or a subnet that has internet connectivity. And you also have to know that they have security groups that have rules that allow them access to the internet. Now, in order to get to this, you may have to do a bunch of analysis of your configuration. But with a graph, and especially if you look at this query, it is fairly straightforward. And what we've also done is we've designed a query language that is close to natural language. It's very readable. It's very human readable. It's even more so than SQL, right? So a lot of folks are probably familiar with that. So what this basically says is find something, right? This is what the query language is doing. Find something with certain properties, in this case, find AWS subnet with public equals true, that relates to something else, right? So that has AWS instance, and then that relates to something else, and again, right? So this builds the relationship and traverses the graph and derives at an answer. Now, this answer can be presented in this visual diagram as a graph, kind of denoted by the return tree kind of syntax in the query language, or it can return you detailed configurations for each one of these resources as well. Now, I'll continue to show you other examples. Here's another example. Now, this one actually has to do with a recent security breach from Capital One. Right, so I think some of us probably familiar with that incident. Now, one of the key things that caused that breach is a misconfiguration of their AWS resources. So what happened was that they have external public-facing systems that had assigned particular AWS IAM roles that has broader permissions than it needs to have. So this is a query that designs to find that. So essentially, if you look at this, the question is, do I have internet-facing EC2 instances that are allowed access to non-public S3 buckets? Now, this question sounds logical, but to get answers to that, it is very tricky. As you see in this query, you have to know a lot of things to get to the answer of this. So you have to know about your security groups and your EC2 instances, the rules protecting them. You have to know that if the instances are active, you have to know which IAM roles are assigned to those instances, and then what policies are assigned to those roles, and then analyze the policies and to see if those policies give access to S3 buckets. And that's not it. You also have to know that are those S3 buckets public or meant to be public, to derive meaningful answers without noise so that you can analyze and remediate. Now, imagine if you have thousands of instances across hundreds of AWS accounts and many, many policies and IAM rows, how are you going to do that? It is extremely time-consuming. You may take weeks just to find the answers to this one question. Now, if we have the data aggregated like this, and with the relationships already built in a graph that you can query, you can get to that answer in seconds. So that's the power of the graph. Some other examples. In AWS, you can have cross-account trust. You can have IAM rows and policies that connect to each other across different accounts. Now, this is another example of finding the roles and the policies and the trust across different environments. I'll zip through some of these quickly because I want to get to the last part of the talk. So there are some things about, some questions you can ask about S3 bucket access. Are there non-public access granted to anybody outside of the account, right? So all of these questions can be very easily answered using the same pattern, using data and query and the graph. Now here's something that's more interesting. We use Octet internally for our single sign-on. So we don't have IAM users directly provisioned in AWS accounts. So we can actually build a graph that looks like this to show ourselves or auditors and see who has access to AWS accounts via SAML single sign-on. Now, that's the result of that. Additionally, you can look at application components and data flows. So not only can you do configuration analysis, but you can actually build a diagram to show from a development standpoint, or as you're building threat models or risk analysis of your applications, how are things connected to each other? So we use serverless, right? So we use API gateways, we use CloudFront and Lambda functions and connecting to other resources. Now this is a graph that shows you how these things are connected within the environment. Vulnerability management. That's another use case for security. Now I'm shifting gears a little bit, right? So this really has not very much to do with the AWS configuration, but you can do the same analysis for vulnerability management using data and graph as well. So we've collected all the information from different scanners, so you can easily build a profile, build a graph, and see what is vulnerable to what CVEs. And you can find the most significant offenders. You can actually easily find which one I need to pay more attention to, which device or which host or maybe which particular vulnerability by looking at a graph. Now, tying this to DevOps, right, tying this to development a little bit more, we can gather development insight because the data can come from your GitHub repos, your Bitbucket repos, as we do, right? So we can say, well, if we have a developer named Adam, who is real, and what PRs did this person open last week? You can actually run a query to find that. Now, why is that important? Why is that interesting? Right? Remember the vulnerability one that I showed you earlier, right? So we can do a full circle. We can tie this back to from vulnerability to code to developer to PRs. So when was the last time you had to spend time hunting down a developer or finding out who contributed to this vulnerability? Right? If you have a tool that can allow you to do this automatically, so this is a query that builds that connection to say, well, I have this code, I have this vulnerability, make the connection. And when was the vulnerability introduced? And I'll look at when was within the same time frame, what PRs, what pull requests were opened within that time frame, and which developers opened those PRs. So there's a very high likelihood of correlation that that developer may have introduced that vulnerability. So you can make those connections with graph and with the queries this way. And of course, and any of these, then you can, the way we've done the implementation of this platform is we allow the security teams to set up alerts to send emails or Slack messages when something triggers, right? So one of these queries triggers some results. Okay. The last part that I want to talk about is compliance related. So security artifacts as code. So we just saw that how we can build tremendous amount of visibility using data and code and query, right? Now I want to show you how we can do the same for compliance. Now using the same platform and using the same methodologies, and we can do compliance as code as well. So when it comes to compliance, the first and foremost thing that auditors look for will be your policies and procedures. Do you have the right policies? Do you have written policies? And do you have procedures for certain things? Now, typically, that is a 200-page PDF in most organizations. Now, our approach to this is a little different. So we wrote all of our security policies and procedures as code in Markdown. And not only did we write them in code, now we have templatized the content of that so that for certain things like procedures, we have procedures as not procedures, we have provider as a variable in the document itself. So if we change the provider, let's say we have a procedure for single sign-on, and today the provider is Okta, and tomorrow we implemented, Azure AD or Google G Suite or OneLogin or one of the other providers, we can simply change configurations, and the policies will get updated and the procedures as well. The other thing that we do is we like microservices. So we write these docs kind of like a microdocs. So they're decoupled, right? So the policies, procedures are all decoupled. So we have about 200 of these little individual files. So what that makes, the benefits of that is it makes maintaining the files a lot more easily. We also use code reviews or pull requests as the review and documentation review and approval process for these documents. What this looks like is you can actually see this in a graph. Right? So this is the same graph that you see before. You can see that I have a policy and I have a set of procedures that implements it. Right? So this provides nice visual proof to say, yes, I have policies, and yes, I have procedures implementing the policies. And you can even branch out and say, yes, I have providers implementing these procedures, and I have evidences for these controls in place, and so on and so forth. Now, what this looks like, the document itself, what this looks like once it's compiling to HTML will be something like this. And of course, you can style it any way you want, but this is what it looks like on our platform. The next example talks about manual assessments and findings. So I showed you early on a graph that talks about the vulnerabilities and the visual aspect of how the vulnerabilities are connecting to the hosts and resources that it impacts, we can do the same with manual testing and manual findings. Now, our security team would write findings and reports in YAML, right, which is a popular format, or you can do in JSON or something similar. And that gets published into the same graph, into the same platform, and you can then run the same report. You can see the same visualization analysis for manual findings the same way as a finding collected by an automated scanning tool. That's what this would look like, right? So you can actually see the connections between somebody, a person, or an employee internally, or maybe an external assessor who performed a penetration testing or risk assessment of some sort. These are manual testings, and they have certain findings, right? So that's what this graph is showing you, right? So those connections and the resources. You can do vendor management the same way. We do vendor management as code as well. So we ask our development organization, product organization to make updates whenever they need to engage a new vendor. This triggers a pull request in code, right? So it triggers a PR, which triggers necessary vendor security review if we need to. And this, again, gets published to the graph, so you can actually analyze the relationships between vendors and the services they provide and who has access to them, and so on and so forth. Now, the last couple of things I'll mention is the design aspect, right? So when we talked about shifting left to the very far and having security considerations as part of every feature function design. So what we do is we internally leverage an RFC process for every new product feature that the engineering team is about to build. And what we said is in this process, right, in this review process, then the template must include security and privacy considerations. So as the engineers who are building a new feature, they are talking about and gathering feedback from their peers and other engineers, they also have to talk about the security aspect and the privacy aspect of everything they are building. And one thing that we added to this process is sometimes they may forget to include the security team in that review, especially sometimes that the feature may have kind of greater security impact and concerns. Now, we don't want to be left out, or we don't want to kind of fall under sort of that mistake, right? So how do we do that? We actually wrote a little automation that detects these PRs from our code repos, or these pull requests that contains these RFCs for security and privacy considerations, and alert the security team via Slack message. So we get notified about every time there's a new RFC being created. So by the way, if you see the yellow bar on top, and we have open sourced a lot of what I talked about here today on GitHub, so you can actually go see it, go find the code, and if you want to adopt it and use it yourself internally, you can see them. So the last part is evidence collection, right? This is the compliance part. The queries that I mentioned to you before, right, needs to be mapped to compliance requirements. So what we do is we use, once again, in code, what you see here is a blob of code that represents a particular compliance framework. Now, it could be SOC, it could be PCI, it could be anything that your organization must adhere to. It could also be your internal compliance framework. Now, it is written in a way that it has a set of security controls or a set of security requirements, and each one just has a reference number and with some descriptions that came from the PDF that was published somewhere. Now, what we can do then is those queries that I showed you before that generates the graph, the visual, can also generate a report, a list of actual data points. Now, these queries are then, here's an example of it, these queries are then mapped to the compliance requirement individually by reference number. So with that, then we can do compliance as code with the queries, right? The same queries and questions that you ask for security operations visibility can then be used to generate compliance evidences. To summarize everything, so I talked about a lot of things, right? So today, first and foremost, the way we approach DevSecOps is having this open and simple and collaborative culture in the organization. And second is we implement security and DevSecOps using data, using code, and using a graph that emphasizes on the relationships, right? Not just a simple list, to build this knowledge base about our environment so we can ask questions about it. And last is this query. The query used to gain insight continuously for both operations and compliance. And of course, tomorrow's session, we'll talk more about the automation in the pipeline that we did. This is my summary, right? So provable security is what we want to achieve, and we're doing that with continuous assurance and continuous compliance. If you have any questions, yes?
Is it Jupyter-1 you're using for query and graph as well?
Actually, yes. So all of the screenshots that you saw before were from Jupyter-1. If you want to, I'll be around. If you actually want to see a demo, I'm more than happy to show you one as well.
Are you automating basically producing actual compliance documentation for any upstream folks who have to see official documents?
Yes. So we are providing actual evidences for each compliance requirement. Question?
One of the things that we struggle with in that space is the desire for the evidence to be the actual state of the running instance on AWS versus any other documentation interpretation. Like if I have code and I say it's an immutable infrastructure, they still want to scan the infrastructure to make sure it's in compliance with the code.
Absolutely.
They don't care about the code.
Yeah. Yeah, so the question is that the challenge is what you think that you've configured in code, is that what's actually in there in the environment, right? So that's exactly the same challenge we have as well. We use Terraform for immutable infrastructure for our AWS environment. Somebody may use CloudFormation or similar. But at the end of the day, you will drift away, right? Your environment will change no matter how hard that you try to adhere to those code that you originally write. So the platform that we did was going directly to the AWS APIs, to the environment itself, and gathering actual data of configurations, not just based on the code that you wrote for the infrastructure itself.
So you gather it on both ends?
We gather it just on the source, from the provider itself. Yeah. But you're right. So if we want to, we can compare that with our Terraform code, for example, and see if there are any differences.
How big of a challenge has it been actually gathering all of that data and getting it into a system so that you can actually process it and make the graph and make the queries?
That is the biggest technical hurdle, right? So to do it accurately, and not just to do it once, but to do it repeatedly, because you can gather the information once, but once something changes, you need to be able to gather the updates, right? And you need to do this continuously and accurately and every time and after. So that is the biggest technical challenge, one of the biggest technical challenge, and that is actually why we decided to offer Jupyter-1 out as an offering, because we think we've solved this. Right, and of course, you can implement this your own. You can build APIs and to send data to a graph database, somewhere. But why recreate a wheel, right? The sort of things. Yeah.
All of your examples were in AWS. Does this work for all the clouds?
It absolutely can work for all the clouds, right? So as a platform, as the Jupyter-1 platform, we so far has focused primarily in AWS. Now we've started adding support for Azure in Microsoft, but the concept, yes, you can work across all clouds.
Do you have any cool demos in Azure?
We can probably chat offline. Yeah, I'll show you what we have. Yeah. Okay.
So you're collecting quite a lot of information, and the next expected step is AI on that. Any thoughts about that?
Sure. So we do have ideas on what we can do from a machine learning perspective and kind of gather more insight, understanding the data, how things change. For example, a simple example would be to understand what are the ephemeral resources in your environment, right? So some things are easy, but everybody's environments are different, right? So you may have 1,000 EC2 instances and they're always there, and the next person may have, you know, like us, where we may have anywhere between 5 to 5,000 EC2 instances at any given time. So the use cases are different. So we have ideas on how to leverage machine learning to do things like that, right? But there are other ideas as well that we're exploring, of course.
Thank you very much.
All right. Okay. Thank you.